Good morning, ladies and gentlemen. Welcome to the Grand Hyatt Taipei, and I hope you have a very pleasant stay at our hotel. And today is a very honor I can present our hotel the energy saving conservation. And today I have the 1 hour presentation. And first 30 minutes I will share the hotel energy saving, and next 30 minutes we will go down to our basement 3, which is our plant room, to see our chiller, boiler, and heat pump. First, I just hotel the introduction. The hotel we are opening 1990, so until today it's about 24 years. And we have the 25th floor, and we have the 120,000 square meter, and we have the 850 bedroom, and 8 restaurant, and a swimming pool facility, and a ballroom meeting room. And here is our guest room. We just fully renovated the 850 guest room recently. And our restaurant, we have the cafe, and Chinese restaurant, Japanese restaurant, bar, and the whole facility. Okay, today I start our energy conservation. Okay, this chart I just share you. If we also more detailed to break down, we know the chiller consumption actually also 50% of the aircon. So of course, how to maintain the good chiller, the high efficiency for chiller for us for energy saving, I think is very, very important. So okay, let me explain the old chiller system still hotel in operation will not affect. And here is the new chiller system. We will see, okay, before it's a 4 chiller, now we change to a 5 chiller. And the capacity is 550 tons for this 5. So the same capacity also I think. So also our chiller water and condenser water pump is with the inverter. That means all the pump, we have the inverter. We know inverter just in the partial load, we can reduce the speed. Reduce speed, also we are get the energy saving. So all the pump is the inverter control. Loading, it can get the more high efficiency of the chiller. So and this chiller can run to under near 15% of loading. I think usually chiller is down to maybe 30, 40 already surge, cannot run it. But this chiller can be run 15, very low. And you look chiller efficiency. So usually the chiller from 0.3 to 0.5 is constantly, so it's very, very good efficiency for the chiller. And also we know the chiller, the water pump, also inverter, but the chiller also is the inverter chiller control. So you can see, and this system is the very good, is it always indicate the efficiency is here. For example, currently the aircon is 868 ton, and all system the consumption is. So in the old system and new system compare, we know our electricity saving, we are saving near 2 million kilowatt hour per year. And we also reduce the CO2 emission by near 1 million kilo the CO2. Next, I want to introduce is produce the chiller water in the North Asia, like Japan, Korea, and Beijing, Shanghai. Because in the winter time, the outside is very cold, even the snow. So, but the hotel still near using the chiller water. So they just run our cooling tower, and this cooling tower water go to the heat exchange and transfer to the chiller water and supply to the system. So that means without run the chiller, you still can get the chiller water. But this system, in Taiwan, I think it's the first hotel we are cooling, especially from December to March. This is 3-4 months we can use in the free cooling. So let me introduce the free cooling system. Here is our free cooling system. The normal the circuit chiller flow the chiller pump goes through the chiller and produce the chiller water to the guest room. But in the winter time, so like currently, we just start all the chiller. By looking, we still get currently the loading. Here is last year December. In the afternoon, the hotel the aircon loading is 339 tons. So the chiller the consumption is the chiller system aircon system is 96 kilowatt. But the most important you see here is our chiller consumption is 0. That means we don't run the chiller, but we still get the 339 ton, the aircon. It's come from where? So it's come from here. So chiller system will not go through here, we go to the heat exchange. And this heat exchange, the other side later I will explain. The other side they go to the cooling tower. That means cooling tower water come from here and heat exchange and produce the chiller water here and the supply to the system. So that means we can get the most saving. Without start the chiller, we still have the chiller water to supply in the winter time. And here is the heat exchange. So here is the condenser pump side. Here is chiller side. So here connect to the cooling tower. And looking this one, up the cooling tower is the 11 degree. And after heat exchange is 13. But the chiller water before is 14 and we drop to 13. And this 13 we supply to our chiller system. So we get the saving. And this is another case. So look, our chiller efficiency, our electric utility cost saving. So to compare the 2001 and 2007, we know because we do all kind of the energy saving. Compare the electricity, we are saving 3.6 million kilowatt hour for the electricity, and for the fuel, we are saving 222 kiloliter the fuel. Also, the water we are saving 74,000 cubic meter the water. So total saving we are saving 17 million NT dollar, probably equally 600,000 US dollar. And also equal probably 20% of the hotel total utility cost. So it's a lot of saving. That's all. It's today my presentation. Any question?
Per area. And also, before you decide to replace this old system, how old are they?
Yeah. Okay. First, our old system, I just mentioned, hotel we are open in 1990. So the chiller system probably 25 years. Yes. Another question, you want to know the replace cost, right? Replace cost, I think we spend near probably 100 million NT dollars. So 100 million is about, I think it's 100 million dollars. It's 300,000, near 300,000 US dollar per order system.
So that is the overall cost?
Yeah, yes.
So including labor?
Yes, all the labor equipment.
How about from being specific, for example, on the cooling tower, how much? Then on the chiller system, how much?
Oh, you mean
on the
separate?
VSD, how much? So that everybody will learn.
Oh, okay. Currently, I have only total. If everyone interested, I think later I can email to you all some kind of breakdown. Okay.
Just so from your slides, you have some data talking about the water consumption.
Yes.
Compare last year and this year. I think when for guest room, the water consumption is increased.
Yes.
So for guest water consumption, have any measures or what kind that you can do to control the water consumption in guest room? If the water consumption is increased
Yes.
too much, how to do that?
Oh, okay. Yeah. Before we say yes, need to control the usage, we must have the more meter. So of course, in higher we have a lot of sub-meter, so we know exactly all the water electricity going. And in this figure, we show why the gas room the water going up, because we know this time our gas room renovation, we are fully renovation. So not only the decoration, the gas room side, also all the plumbing we are replaced. But currently, because the plumbing MVP side, we had some challenge because some problem we need to constantly to blow down the water. That means the reason, so our water consumption is going up. And currently, hotel and the contractor, we are still try to find out how to solve this system problem. So after I think we solve this problem, definitely we can see the consumption is down. Thank you. In the winter time also we heating our swimming pool, but currently we are using the steam. So, but I mentioned we have the heat pump. Actually, heat pump is the running cost is very low. So we are planning in the future, we just connect this heat pump, hot water, to heating our pool. So definitely we can get the most saving. And another is we're talking the LED. LED, actually everybody knows is energy saving. So currently our plants outside our building light also consume another the electricity. It's not LED. So we just finished tender. So we will change the whole building outside lighting by LED. So it costs about 10 million to replace. I think very soon, probably this project we will finish by end of this year. So after that, I think we also get another LED saving. Yeah. Hope that answers your question. Thank you.
Idea to consider the install your PV solar panel on your roof to generate your own renewable energy for decrease your CO2 emission.
Yes, this plan also we are studying because in our roof actually the area is not so big. Yeah, it's not so big, and we know that the solar the immense cost also is very high. So, but I think that's a goal. Definitely, we will go for this now to get because it's more environment and more saving. Yes.
2 years or 3 years or 5 years later? Have any idea?
Yeah, probably 3-5 years later. Yeah, we have this plan. Yeah, yes.
Electricity, the temperature you always set it at 22 degrees C.
And the low speed.
At low speed.
Yeah. Before, if you set 21 or 20, but in the high speed, but when you take out the key card, automatically you will drop the low speed and the 22. Yeah, to maintain this.
So it means that the 22 degrees C is the maximum. It's the good, the best condition.
Yes, you will always maintain this temperature. Yeah. This is in our experience. Of course, maybe we can set 23, 24, but in our experience, you will set 23, 24, we get a lot of complaint. So then, so we set 22 is like a standard, but the low speed. Yeah. That's the current setting. Yes. Yes. Thank you. Okay, if no other question, then maybe we can move down to our basement, our plant room, to see the new chiller, boiler, and heat pump. And next door, we have the elevator, so we can go down to the basement. And in the basement, we have the 2 teams, so we can separate 2 teams, probably 10 minutes, and switch over. Yeah. Okay, thank you.